All right, guys. Uh, with this video, we're going to start with section 5.6. Okay, and it is about solve quadratic equation by factoring. So one of the example that we can look at for this concept is 2x squared plus 5x minus 3 equals to 0. Obviously has an equal sign because it's an equation. All right. So the first step is to set it equal to 0, but this one is already equals to 0. So step one is taken care of already. Okay. Step two is to factor the quadratic. Step two, factor the quadratic. With this, you can't use grouping. There's no GCF. Okay, but you could either use trial and error, um, AC, or change the grouping, square root method, or you could use the AC method. I know we've done a lot of Columbia method, so you already know how to do this method. But let's consider the AC method for this one. Okay, in the AC method, you would start this with the same way you start with the Colombian, except and then you're gonna start taking a different direction so you could do the AC. What I'm saying about the same approach or the same start is to multiply the coefficient of the A term by the -3, which is a C term, which would give you your -6. So this -6, when you break it down, if you divide it by 1, it's still going to be 6. If you divide the 6 by 2, it's going to be 3. Well, you still need two numbers when you multiply. It's going to give you -6, not -3, but -6. And once you add, to give you a 5. Or those numbers is, if you make the 1 a negative, then you can multiply the -1 by 6 to get you a -6. And you can take away 1 from 6, which means 6 minus 1. It would give you a 5. So plus 6 and minus 1 are the numbers you're looking for. Well, with the AC method, remember it's not Colombian. With the AC method, all you have to do is drop the first term as is. Okay, you will write the middle term with the -6 and I'm sorry, -1 and +6. Then you would then write uh plus 6, add an x to it, minus uh x, and then minus 3, and still equals to 0. Okay, that's the setup for the AC method of change to grouping. Change to grouping because now we can group these, right? Now it's 4 term, we can group these. Okay, creating two parentheses. Now we can factor out the GCF from each one. Okay, so here the GCF would be 2x. If we factor out 2x, what we have left is x plus 3, right? And remember, you have to factor out the leading sign, which is a negative. So you would factor out a -1 from that, because all you can factor out is the -1 from this parentheses. So if you factor out a -1, then you would end up having an x, and this negative would change to a positive plus 3, because if you end up distributing this -1, then you're going to get exactly what you have up here, equals to 0. Okay. Then to finish your factoring, you're going to write your remainders. Okay, 2x minus 1, 2x minus 1 inside of one parenthesis, and then you notice you have your two twins and drop one of the twins, x plus 3, and that's it for your factoring. But you obviously have to set it equal to 0, which then step 3, if you want to think of it like this, you could set each parenthesis equals to 0. Okay, x plus 3 equals to 0, and this side you add 1 and add 1, and then 2x is equals to 1 divided by 2 divided by 2. This is gone, so x is equals to 1/2 for this side. For here, you subtract 3 and you subtract 3, x is equal to -3. Okay, so those are the solution. Well, the further step that you can take, by the way, for the exam or for any question that you ask, those are the answers that will be required of you: 1/2 and -3. But I'm going to show you really quickly how you can check your answers. Okay, if you want to call that step 4 or 5, but it's just how you can check your answer. And we're going to do it for each one so you know how you can check your answer once you find each answer. So our answer is 1/2 and -3. So I'm going to write these so you know. So 1/2 is one of the answer and the other one is -3. So to check these answers, what you would do is you would plug the 1/2 in for the x. So 2 times the 1/2 squared, because this x, okay, 1/2 squared, plus 5 times 1/2, okay, minus 3 is equal to 0. So then you have to square this first using PEMDAS, okay, order of operation. So 2 times 1 times 1 is still 1. 2 times 2 is 4. So you square that first. So it becomes 1/4. Okay, 2 times 1/4. Okay, plus 5 times 1 is still 5 over 2 minus 3 equals to 0. Okay, well, 2 times 1 is still 2 over 4, and then plus 5 over 2. Well, one thing you may see is that you can simplify this. It becomes 1/2 over 5 over 2 minus 3 equals to 0. And then you add the 1 to the 5, it makes it 6 over 2 minus 3 equals to 0. But technically, 6 divided by 2 is 3. So 3 minus 3 equals to 0. Well, 3 minus 3 is 0. 0 equals to 0. So that tells you the 1/2 solution is correct. It is a solution because it ends up being 0 equals to 0. So the next one, which is -3, if we check -3, should work the same way in order for you to consider it to be a valid solution. And just remember, this is just checking your work, because you already had your answer, which was 1/2 and -3, and now we're just checking them. So if you have the 2, you plug in the -3, obviously -3 squared, because that's what the x is. You plug it for x, -3 squared, plus 5 times -3 instead of the x. You substitute -3 for that, and then minus the 3 that was already in the equation equals to 0. -3 squared would give you a positive 9 times 2 plus 5 times -5, which would give you a -15. So that's minus 15 minus 3 equals to 0. Okay, 2 times 9 is 18. 18 minus 15 minus 3 equals to 0, which is technically 18 minus -15, -3, which is -18. Okay, -18 equals to 0. 18 minus 18 is 0. 0 equals to 0. So that tells you both solutions are valid solutions, because when you check them, it's 0 equals to 0, which is valid. Okay, that's how you check your solution. I know it's kind of long, but that was just to show you how to check your solution. Thank you.